Hi, I'm Dave Robinson, and welcome to another screencast where I'll be analyzing data using R that I've never seen before. So as usual, I take data from the Tidy Tuesday project from the R for Data Science online learning community, I bring it into RStudio, and I perform some exploratory analyses on it. So this week the data is going to be on women in the workplace. So this is Women's History Month. This week, I believe this week is International Women's Day. So this is exciting. We have some data about, it looks like, women's earnings and employment status, and detailed information about specific occupation and earnings from 2013 to 2016. Okay. All right. It's worth remembering I'm not a scientist studying this. I don't have all the context, so I'm going to do the best I can to report the trends that are and analyze the trends that are present in the data. It's not going to be able to control for all the confounding factors that are a part of this of these data sets. All right, so I do not the original come from Excel. I don't recommend cleaning them. As an exercise, there are some major gotchas that are less than enjoyable. Okay, so we're going to work with the clean data here. Jobs, gender, earnings, female, employed, gender. Looks like 3 tables. Ooh, that's a whole bunch of cleaning that Thomas Mock did to set up this data. But we're going to be working with the clean data. Okay, so I'm going to go into RStudio. Going to do a new R Markdown. Women in the workplace. Library tidyverse. And grab data on jobs by gender, earnings female, employed gender. Okay, let's take a look from the first one. Jobs, did I run a line wrong? I'm getting a 404 on this one. Oh, gender, I think this is, perhaps this was renamed. And take a look. Yep, looks like it's renamed. I should do a pull request to fix that link. Maybe I will afterwards. Okay, so we have is year, occupation. Oh, each occupation comes from a major and minor category, and falls into workers. Okay, total earnings, male, female, wage, percent of male. Okay, so we're looking at, it says 2013 to 2016. We're going to start with the jobs gender data, and let's see. I wonder how many occupations are represented. 522. Are they all, presumably they're all across all 4 years. So I'm gonna, let's see, I wonder how many major categories there are. So I'm gonna count major category. All right, 8 categories. Okay, so we could start with that. All right, I have some ideas. I think I'm going to start with a couple visualizations based on major category. If I want to look at these by major category, what I want to look at is total workers. I want to include anything that it can be summed up. I'm going to aggregate across, starting with a major category. So I'm going to group by year and major category. I'm going to look at the minor category later, and possibly the occupation. But I'm going to start by year, major category, and I'm going to, let's see, what's total earnings? Does that mean the average salary? Does it mean the total salary of people in that group? Total estimated median earnings. Okay, so the estimated male median earnings. Total, I imagine. I imagine total would mean combining salary and bonus. It doesn't mean like it's the sum across all people. That's worth understanding. Okay, let's see. Okay, I'm going to start by summarizing, and I'd start with, I could do each of these totals. I'm going to do a summarize at. I'm going to say anything that contains the word total. No, I take it back. The ones that contain the word workers, I can sum up. This is going to be a little harder than I thought. Anything that includes the word workers, I can sum up. Anything that includes the word earnings, I can take. I'd have to do some kind of weighted average. Okay. I'm going to return to this in a second. No, I'll stick to this view. Okay, what I'm going to do is say total workers are the sum of the total workers. Now I could I'm doing this by group, by year, and major category. So in 2013, there were 6.5 million people in computer engineering science category, and 14 million people in the service category. Okay, total male. Is it total workers male? Is sum of workers male, workers female. All right, so I can aggregate across these three. It just occurred to me I'm going to be doing this a lot across a couple different types of grouping. Maybe was seeing whether to write a special function for it. Okay, I'm going to try this. I'm going to say summarize jobs gender. I'm going to write a new function. It's going to take a table of jobs gender that's been grouped, and I'm going to do two aggregations on it. This is what I was thinking about earlier when I was saying I want to summarize the total of these columns but the median of others. I'm going to say summarize at. Everything that includes the word summarize at is super handy. Anything that includes the word workers, I want to sum. So totals. Anything that includes the word let's see, anything that includes the word earnings, but not total earnings. No, but including total earnings. Anything that includes the word earnings, I want to summarize at vars contains earnings. I want to do, see, this is where it just got confusing. I just realized I can't quite aggregate this way because it's going to be a different aggregation. One of the median within each, the weighted median. Oops. Okay, I may have been going a little overboard with the abstraction here. I'm going to set up here. I'm going to say earnings are total earnings. What I'm doing is taking a weighted average. I'm going to say sum of total earnings times total workers divided by the sum of total workers. That's a weighted average of the medians, which is interesting, but it's all I can do out of this particular data. For total earnings male, I'm going to try the same thing. There are other ways. Total earnings male, workers male, divided by the sum of workers male. Do the same thing for female earnings. All right, because what I'm trying to do is do an aggregation so I can get a feel for this across large categories. Total earnings female, workers female, sum of workers female. Here we go. All right. I'm going to apply this function. The reason I wrote this out is I wanted to have this aggregated version when I needed it. I also noticed, where are there NAs? I could imagine a couple places there are NAs. This would be under total worker earnings male. Okay, where would let's see, jobs gender filter is NA. Start there. All right, there's areas where there's 0, at least in this data set there are 0. Okay. And that's workers, 0 workers male, and also NA, total earnings male. Okay, so I want to, sum of, that's funny, is the NA times the 0 is going to be, all right. NARM equals true. I actually need a little trick here just in case there's cases with NA. Well, actually, let me find that out. Where are there ones that have NA? There's a neat trick. Filter not complete cases dot to say where is there an NA anywhere? And ask the question like, well, it's mostly wage percent of male. All right, if I remove that one, total earnings, we have a bunch of total earnings female. It looks like there's a bunch of cases where we don't have one of the values. Okay, and it's not necessarily 0, it's just low. Okay, in that case, I need to make sure to do this. To say sum of workers male where is not is NA total earnings male. Yeah, this is why I'm putting this up into this own function, is that it's not the easiest thing to do. What I'll say is not is total earnings female. Okay? Look at me making mistakes here. Not is NA total earnings. Let me see. I want to say sum of this column divided where not is NA. What am I think maybe, does this change anything? It does. Surprised me. I wouldn't expect to have NA here. Okay, something's also wrong with this. Let me see. Not is NA total earnings. All right. If I tried just, this is going to be wrong, but if I tried just saying complete cases, I would still be missing some examples. Let's see. I would say filter complete cases. I would say, let me see. I wonder if, do you spot my mistake? I don't spot my mistake. Total earnings times this. And if I removed each of these, where is, it would be, I do need to add an ARM true here. Why is some, where not is an A total earnings male, it's as if this field were always an A, I would get this result, but I'm not, it's not. Total earnings, all right, I'm going to try looking at one example. All right, so I'm debugging now. I made a mistake here. Let's look for just year is 2013. Major category equals service. If I summarized it just into, let's say, this value, the numerator. I would get, oh, I see, okay, this value divided by the sum of, so that one field does work. But if I, oh, okay, I see what I did. Okay, these values end up, this is one of my most common mistakes. I made it before in the screencast. This new value in the summarize gets used here, which is a really big mistake. I'm going to need to move these. If I move these after, think nothing depends on earlier ones. Okay, let me take one more look through this, because I could really mess things up if I get this wrong. I used a weighted median wherever there is a salary, okay, and then total workers, workers male, workers female. Okay. I think this variation worked. All right, now that I have this, I can say I want to plot year. Let's start with total earnings, just overall total earnings, geom line with major category on the color, aesthetic. Major category is too long a name. All right, so we generally see the highest are computer engineering service, followed by, am I right, this is, Yes, I believe this is management, business, financial, natural resources, construction. Nope, that's down here. Whenever I have this, it's nice to say mutate major category equals FCT reorder the major category by the total earnings. And usually I would do descending, so I actually could say by negative total earnings. Here, I'm going to try this again. I meant to do a pipe. This reorders the columns so that it's easier to read them down the list. So it's it's healthcare practitioners and computer engineering, management, education. That's management, education, natural resources, sales, office, production, service. Okay, that's this variation of this line. I would also say expand limits y equals 0. Okay, that's just the overall total earnings. All right, I'm going to call this by year major category. That's an aggregation. I'm also going to save this. Okay, let's also separate it by men and women. I'm going to start, I'm going to start by representing with a gender gap. So I think this mentions it uses female wages as percent of male wages. So I'm going to start by adding a column here that is, I could actually do it in the summarize step. In my summarize function, I want to add, just like we had in the original data, wage percent of male is going to be, it's going to be total earnings female divided by total earnings male. And besides this first graph that shows the total salaries, I'm going to try showing the wage gap, show the wage percent of male. I'm going to do that both here, percent of male in the reorder, and I'm going to do it on the y-axis. Okay, so we see gender gaps. All right, yeah. So we see gender gap. It's smaller within computer, just across a whole major category. Small within computer engineering science. It's because a higher wage percent of male. I'm gonna drop the Y0 because everything's above 60%. It gets a little harder to read. All right, it looks like the wage parity is increasing in natural resource construction maintenance. The rest of them have hovered around 70 to 75%, and there's a much larger gap in healthcare practitioners and technical. Okay, I have a guess about healthcare practitioners. I'm guessing this is an example of a variation of Simpson's paradox. So my bet is that within healthcare practitioners, there's a huge imbalance where women are disproportionately in lower paying jobs within healthcare, including nursing. That's probably going on to some extent within every major category. It's probably biggest in healthcare practitioners. So it's not so much that within the same roles there's this giant imbalance, rather that in healthcare that's larger than other fields, rather than healthcare practitioners has the biggest difference in terms of what jobs are skewed in which directions. We're going to take a closer look at that. But first I could start by looking, in fact, we can look at that. So generally, the only one I see a big difference of changing over time is natural resource construction maintenance. The fact that I'm not seeing enormous changes over time means at some point I'm probably going to be taking a look just at 2016 data so we can zoom in a little more. It is after looking over time, I look at the most recent data we have. So I'm going to actually say by minor category 2016. And from that, I'm going to do jobs and gender. I'm going to filter for, let's see. I'm going to filter for year equals 2016. I'm going to group by the minor category. I'm going to perform my summary by summarize jobs and gender. So I did a different aggregation than I did before. The last time I did it across all years. Here I'm doing it for 23 categories. I'd actually probably like to do it within major category as well. That way I keep all the data. If I want to ungroup it, Doesn't hurt. And now I have it within major category and minor category. Okay, so what do I see about gender gaps within, let's say, let's see, I'm going to do it within all of them. Here's what I'm going to do. I'm going to say, take this and say, let's look at the gap within each minor category. Geom, a bar plot, coord flipped, and a quick reorder. I'm going to say reorder. I'm going to use FCT reorder. Minor category by this. So within each minor category, what do I see that these are so healthcare practitioners and technical is a whole minor category. If I tried fill equals major category, I was expecting it to break that down a little bit more, but it doesn't. Okay, so there's only one minor category within it. Okay, so we can see that, for example, within community and social service, aggregated in that minor category within I might want to facet this instead of coloring it, or I can still color it, but I can say show legend equals false, and I can say facet wrap by major category. I'm definitely going to want scales equals, I think it's free. I'm doing a coord flip, but I need to make sure, it's free Y. I need to make sure that they're separate on each of these dimensions. That faceting, the problem with the faceting is I don't have nearly enough space here. Okay. Yeah, that's a real problem. I don't, yeah, I probably can't facet it when these names are this long. I could try shortening them. It's probably not worth it. I'm going to skip the faceting plan. Okay, but do I see any trends? Some of the ones with the closest, so we still see healthcare practitioners, which was not broken down, still has average woman in that field making only a little more than half the weighted median in that field, making only a little bit more than half. And we see areas with closer wage parity, including that's closer to 100% female divided by male. We see community and social service, construction extraction. Okay, I don't know what to make. Yeah, I think I'm going to have to zoom in a little closer. Certainly, I'm interested in the healthcare practitioners and technical. Also interested in legal, but let's start with healthcare practitioners technical. Let me try looking. So that's within each minor category in 1 year. I'm going to look. Filter major category is healthcare practitioners. This is and technical is the name. Okay, we have 32 jobs here, so I'm interested in what is driving the wage disparity. Is it within the same job? Looks like at least sometimes there's. Wow, that's an enormous. Nope. These are totals. These are not prices. These are not salaries. Oops. I'm going to start by doing a range, and I'm going to rather make a graph. I'm going to look at it for a moment. So, if I'm going to view it, I should probably select just. What am I going to do? I'm going to select occupation, total workers, workers female, wage percent of male. I'm starting there. I want to get a feel for the data for a moment. Okay, it looks like there's a few areas. They don't have as many workers in general, and they tend to be female dominated, where women earn the median woman earns a bit more than the median man in that field. Okay, and then sliding down this, but only a few. Sliding down the scale, various nursing professions, there's about a 10% pay gap. And then we have a number of areas. These are relatively few. there's missing data. I guess there must be missing data. If I look in the original, I just want to get to make sure I was measuring the missing data right. If I say occupation is oh, okay. It just for anything below a certain sample size. I remember this was NA. Okay, so this was the original data. Right. Yes. Okay. What we can generally see is what is driving the imbalance in healthcare practice. Well, let's start with what is more male, what is more female. Okay, so if I look at total workers, this is a really common graph I make. I say on the x-axis I'll put total workers, and on the y-axis I'll put the percentage. I think I actually have this in the data. I have percent female. I don't love having it on a out of 100 scale, so I'm actually going to do it myself again because I can't do scales percent. I'm going to do this myself. Workers female divided by total workers, geome point. Almost certainly going to need a log x-axis, scale x log 10. Okay, and add a geome. I'm working on a plot here. I don't need this line anymore. I'm working on a plot here where I'd say, let me see. I'm going to try something. I'm going to try color equal, so let's see, the y-axis is, and color is going to be wage percent of male. I'm going to need to scatter it a bit differently. I'm going to need to use different scale. I'm going to say scale color. I really like gradient 2. Low is red, high is blue. Low red to blue. Okay. Midpoint, I see about the midpoint will be about 85. Oh, the wage percent is out of 100. I'm going to do that divided by 100. Or I could compute it maybe I'll just compute it myself. Say total earnings female divided by total earnings male. Same thing, but yeah. The mid color should really, I'm going to make it pink to be in between red and blue. I don't like the white points popping up. Having said that, I am going to change the theme. I'm going to say theme set, theme light, so we have a lighter background. Okay. All right, what I'm seeing here, you know, what's really interesting here, it doesn't surprise me, but I was starting to get a sense of that from the table. But it looks like the areas that are less dominated by women. This is, I'm going to add better labels for a moment. So let's see, total number of workers. Y is percentage workforce, put it as female. And color is median it's going to be a long I might need to do to change that axis. What this is mostly showing, okay, so the reason I put this on a scale is it's good to focus on some of the bigger jobs. That is, some of the jobs held by more people. Those will be driving a lot of the wage gap. We're seeing, like, really there are a handful of jobs with more than, there's about 300,000 people in between 100,000 and 1 million, where you have large gendered imbalances. So most people in there aren't here mostly women, here mostly men, and the pay gap goes along with it. So this is and this was my initial suspicion, is that you can see These are your fields actually where I think the average woman was earning a bit more than the average man, and they tend to be the more female-dominated professions. Um, Here, the more male-dominated professions tend to have a larger pay gap. I'm guessing this is doctor and this is nurse. It could be a bit more subtle than that. I'm going to try making this an interactive plot. I'm remembering now, because I've actually did something very similar in my first screencast. Let me see. I'm going to try saying library GG plotly. Why interactive? Because I like to mouse over points and get a bit more data about them. And I'm going to say library GG plotly on. Oh, I must have done a. Oh, it's just plotly, right? Library plotly. And here's my interactive graph. It doesn't have the name fields yet. I'm going to add a field called, say, label equals occupation. It's going to give me a warning, I think. It's going to, no, it doesn't give me a warning. Does this give me, there we are. All right, so what we can look at is registered nurses. This is both the most common job in the data set, the one with the most people, and one of the ones with, and it has a smaller pay gap of, it's about 90%, median woman earning about 90% of the median man. And here's physicians and surgeons. So these are two types of nurses that tend to be more female and lower pay gap. These are this is an area that is 2/3 men, and has much a larger pay gap. We can see the same. Let's see. Opticians has larger pay gap. That's the opticians is one that is the opposite direction. I'm going to change my plot axes a bit. I'm going to put. Notice what I'm most interested in. I'm going to put on the x-axis the percentage, this on the y-axis, and say size is the total workers. This is going to take a little bit of effort. So I'm going to say size is the total number of workers, x is the percentage of workers reporting as female, y is this value, and color is nothing. I've got a thesis in mind now, and I'm trying it out. Are these the correct? Oh, I can drop the scale x log 10. I might need a scale size log 10. I'm going to return to that in a moment. I'm going to put the library plotly up here. I'm going to zoom out a little bit. Here it is. Okay. And I'm still setting the wrong color. Well, color is not the wrong color, but color is no longer a necessary axis. Yeah, I don't think I need a log scale on size necessarily. Okay. In fact, I might though want the size to be a bit bigger. I might want to say scale size continuous. Say, so there's this field range. If by default I believe is 1 to 6. If I said 1 to 2, all my points would end up being basically the same size. If I said 1 to 20, now the points are very different sizes. 1 to 20 is too much. But I might want 1 to 10. I might want a slightly more dramatic depiction of the difference in terms of number of workers in each of these. Okay, it's not a very polished graph. Notice that each of these mouse overs is kind of the tooltips have lots of information in them. But at least it is able to tell me a lot. It is able to tell me that, let's see. So some of the jobs with the most people, so first of all, there is a general correlation. That is, we have jobs that that are largely female, like registered nurses, licensed practical and licensed vocational nurses, jobs that are mostly female and have a smaller pay gap. There are also jobs that are mostly male, like physicians and surgeons, and dentists, chiropractors, that are both largely male, 25% reported female, and larger pay gap. So this correlation, like I said before, is probably a lot of what drives the gap. Actually, it's interesting. This is in fact a good example of Simpson's paradox, because take a look at this. There's no individual job where the median female salary is less than 66% of the median male salary. Not that gap is okay either, but there's no job with a gap lower than that. But if we take a look at the aggregated data in our, let me see, in this plot. Nope, this one. The aggregated healthcare practitioners and technical, so the aggregated wage gap is actually is closer to, this looks like 55%. So if I actually look at, here it is, by year major category. If I actually look at the healthcare practitioners and technical, we have a 55%, that the median woman in this field makes 55% as much as the median man. And that is a bigger gap than there is in any individual job. So that's because it's because there are wage gaps in almost every job, but also there's a shift where higher percentage female has a smaller gap. Okay. So that's some ways of looking at this and understanding what's going on in the healthcare tech data. It's good to show a visualization, an interactive visualization like this at a step like this in the process, because it helps us understand some of the trends within it. All right, my own job is within the major category of what is a computer engineering science. Take a look. Computer engineering and science. So let's take a look at that as well. I could do, I could copy paste I could take the exact same code and just take a different major category. Computer engineering and science. Oh, and here I can actually say color equals minor category, and that could be an interesting, I can drop this from both my graphs. All right, what am I missing? Computer, maybe there was an Oxford comma, computer, and was it computers or distinct occupation? Oh, it's, let me see, distinct major category. There is an Oxford comma that I missed. All right, there's an enormous outlier here. Survey researchers that has median much higher. I could filter out just this one example. I don't like to filter just one example, but there are a lot of jobs here. I could try saying only ones with at least 2,000 workers. I'm going to start there. Let me see. But first, I do want to take a closer look at what would that remove. So I can sort by, here we are. The only 4 ones to remove would be like mathematicians, survey researchers, social science research assistants, agricultural engineers. It's strange to me. It says there are only 1,200 mathematicians in the country. That feels like an underestimate. I don't know the details of this data. Maybe mathematicians are counted differently. Okay, so I could probably remove even more than this, but yes, it looks like, actually, in this data, they removed a lot of, see, this is why maybe doing wage percent of male might have been a good idea. Let's see. I'm going to start just by removing any that have less than 20,000 people. I'm going to start there. Filter years 2016 and total workers at least 20,000. All right, so still plenty of occupations. We don't see the same correlation that we did in healthcare, where no, it doesn't look like we do. Where we don't quite see the same correlation where the areas that have the most women also have the largest gender gaps. No, sorry. I mean, there's most women have the smallest gender gaps. In fact, this is the field with the largest percentage female within it's psychologists. It's the only, not quite the only, but almost. It's the only field that is substantially female dominated, and it does have one of the larger pay gaps. So that's something worth noting. So we see a slightly different trend. Okay. And in turn, we see that one of the least female areas is what is it? Computer network architects, but it also does not have a pay gap. That could be it could easily be a sample size problem issue. That is that we don't have a lot of people in this data set. But still, I'm not seeing the evidence of the same correlation we saw in healthcare. Within categories, we see architecture engineering tends to be the least female, followed by computer mathematical, and life physical social sciences, the highest fraction of the highest fraction female, though with the exception of psychologists, still not reaching generally gender parity. Let's see. Okay, I'm gonna also I'm gonna add a few more. I'm going to clean this up a little bit and say labels equals percent format. I'm going to do library scales up here. Oh. Scale on X and on Y. It still doesn't show up on the tooltip. I actually don't know my way that well around Plotly. Yeah, so this exploration, let's see. Yeah, it's a useful exploration because what it's showing is let me see, we can look at individual jobs and see where they fall, and we can look at some of the most important, some of the largest jobs, the one with the most people. Here's software developers, application system software. We see a moderate, in this particular data, we see a moderate wage gap. This is in 2016, and wage gap of about 13%. And we also see, and it is dominated mostly by men, less than 20%. A bit less than 20% female, according to this data. Okay, we also see, so we see some of the trends. We see trends in the subfield, in the minor occupation. We see probably not a real negative correlation, but at least not a positive correlation either. All right. That's between percentage female and the wage parity. Okay, so that's another occupation. I'm going to. I would, at this step, if I wanted to share this with someone, I wouldn't want to share just general trends because I think it's a little important to be able to dig into this because of the Simpsons paradox problem that we've been seeing so far. It's useful actually to be able to dig into the data. So I would create a Shiny application. I haven't done a Shiny application yet in one of these screencasts, but I'm going to go ahead and do it. If I say create a Shiny web app, a single file one within this directory, and I'm going to call it workplace app, create. Okay. I could make it a Shiny dashboard, add a whole bunch of things, but I'm going to just have one input, and that's going to be occupation. So I'm going to have an initialization code. Oh, I've only looked at one of these. I'm going to set up these data sets. There's so much to be done here. I'm going to use only one of these. I'm going to say, notice I've been changing the occupation. So I'm going to say major occupation. Oh, I'm going to call it major occupation and say major occupation. It's not going to be a slider input. It's going to be a select input. Single select with the choices being the unique values in jobs, gender, occupation. If you haven't seen Shiny before, this is how I'm setting up. I'm setting up a UI, and I'm going to call it scatterplot. I'm going to call it jobs scatter. Could be called kind of anything. Output jobs scatter. I'm going to render the plot, but I actually render plotly. And I'm going to do it based on our data here. I'm going to say use the polished version. Okay, and I'm going to say total number of workers. I'm going to say wage, gender, disparity, and wage and pay gap in 2016. I guess I could call it. Let's see. Gender, occupation. I could call it disparity explorer, I suppose. I could name it. I just like to tidy this up a little bit. I don't need the boilerplate. And I only need ggplot2 and plotly here, and dplyr, of course. Using a lot of I use some dplyr here. Okay, I'm going to try this. Oh, I made a mistake here. It needs to be major occupation. Oop, major category. I'm going to call it occupation category, even though I know it's actually called major category. And I made one other mistake. Here in the filter, instead of having computer engineering science, I'm going to say input $ major category. I think that's right. Okay. And this is an output. Render plotly. Oh, it's plotly output, not ly output. Called job scatter. Okay, I just need to line everything up. I've got some gender confusion here. Sorry, title label confusion here, where I see total number of workers. Where'd that come from? Total number of workers. Where'd I put total number of work? Oh, on the size. Maybe I dropped this. Color equals. I'm going to add that. Color equals minor category. Okay, something's up with. I'm going to tell it not. Something's up with. Let me see. I think this probably is a ggplotly issue. I'm going to open it in the browser. It's a little. That looks a little better now. Okay, so it's also a little crammed. I'm going to. It's in the UI output is the problem. So let's see. Plotly output. Height. I don't really know my way around heights, but maybe 500 pixels is better. Maybe, let's try 700 pixels. Let's see how that looks. Yeah, that looks pretty good. Okay, so this is an Explorer where I can choose an occupation category. I can look at our healthcare practitioners and technical like we did before. We see a positive correlation. We see each of these bits of information here. I'm also going to rename, it's a really clumsy tooltip. I'm going to rename total earnings female total. Notice it looks clumsy because I have this step where I say the X is here. I'm going to add a couple columns beforehand, pre-compute them. It doesn't make it look much better, but I'm going to say percent female equals this, workers female divided by total workers, and say wage percent female is this. Why am I doing that? It looks a tiny bit, it's going to look a tiny bit less confusing on each of the tooltips. Again, if a bit more time and experience could make the tooltips look a little bit better, like actually pop up as percentages. But here, yeah. Do I say, somewhere I say only look at, yes, I look at only ones with at least 20,000 people. I probably add that as a subtitle. I say only occupations with at least 20,000 workers total. All right, so notice, I'm going to look through a couple more of these. Here we go. Okay, here's my dashboard. And yes, I can see management. There is not a real correlation between areas. The occupations that are more female, like here, compensation benefits job analysis specialists, okay, or human resources workers. They don't necessarily have a greater wage gap than ones that are mostly male, like construction managers or farmers, ranchers, agricultural managers. It's not necessarily, we don't see a correlation. All of them are not great, kind of hovered around 80, the median woman earning 80%, the median man, the median man in these occupations. And yes, some of the ones that are most female, like meeting convention event planners, have the least wage disparity. Okay, we're still not, in this examination, we're not looking at all at what the total wages are. It could, but that's another major part of the of what drives gender disparity across one occupation category. But here we go. Sales and office, maybe a slight correlation. I can see that office administrative report and support tends to be more female, and actually that's an interesting one. Office administrative report tends to be more female and have a smaller pay gap compared to sales and related, which is like areas like this tends to be less than 50% female, and we see a bit of a larger wage gap. See by these couple categories. How about within the service industry? There is not a correlation, but we definitely see it goes from healthcare support down to building, grounds, cleaning, maintenance in terms of some areas that are female dominated or male dominated. But the wage gap doesn't show big differences between them. Okay, and a little more within education legal. Maybe a correlation, it's a little hard to say, but we can say that that the minor categories that tend to be areas like education, training, library that are more female dominated, and arts and design is kind of balanced around the 50-50. Most of them have pay gaps between, let me see, 10% pay gap, 20% pay gap, 30% pay gap. All right. So you can explore this data yourself and find out more about the jobs. Notice this is a standalone application. It actually doesn't even require external data. It reads in the data at the start time. So this could easily be, I'm not going to do it, but this could easily be published to Shiny Apps. Gender, occupation. Occupation and Gender Explorer. I don't know. I don't have a big name for it. Okay. So notice what I did there is I made one graph. I was interested in it. I realized that it was better being interactive than it was being a static figure. Then I made a second graph with just one difference, filtering for computer engineering and science. And as soon as I made both of them, I'm going to go ahead and polish both of them. But as soon as I made both of these graphs, I realized I probably wanted to make an interactive application where someone else could jump between each of these and explore each of these a little deeper. So that's when I created a Shiny app. And you notice it took just a couple minutes, but it created a dashboard that I was able to analyze this in a bit more depth. Yeah, so that's some of the real power of Shiny. I'm really impressed with what our studio has done to build up to make Shiny applications easy to build. Okay, so to review, there were a couple data sets, but I actually only looked at the jobs gender data set, which had, let me see, it was about 500 different jobs spread across about 8 different major categories. It looked across a couple years, and I looked a little bit at changes over time, and both in terms of overall salary and in terms of the wage percent male. we were interested in digging deeper into healthcare, so I created both first a static visualization and then an interactive visualization looking particularly at healthcare, and then I realized I'd want to make jobs within healthcare, and then I realized I wanted to make an interactive exploration of it that I did with the Shiny app that's visible here. I'm excited. I've been looking for the chance to build a Shiny app as part of a screencast. If I'd had more time, I probably would look at not just the gap within each occupation, but the different salaries that make up each occupation. So, for example, I didn't think of this until now, but it's the clear follow-up question. If we look at it within healthcare, we have the gender disparity. We also have the pay gap within that occupation. But I didn't here look at gender disparity versus the average wage. That is just across everyone in the field. So I could just change one line. Let's take one look at that. If I say instead of looking at total earnings female over male, I take a look at total earnings. I'm going to say total earnings. Probably need, and I would drop this percent. Yeah, so this is actually a very important visualization as well. I'm going to have it, I'm going to have it go to 0. I'm actually going to say continuous labels equals dollar format. This is in America, I believe, so it's so these are in dollars, and I'll need to change the label median salary. So the two conclusions that I draw from in terms of the healthcare disparity. One was that the fields that were more male-dominated had a larger wage disparity. But the second is that the areas that are more female-dominated tend to have lower salaries. The highest median salary occupation is physicians and surgeons, and that is one of the ones that's dominated by about 2/3 male. Whereas some of the lowest paying ones within it, like vocational nurses and support technologists, technicians, tend to be the areas that are female dominated. So this negative correlation is also an important part of it. It's not all negative correlation. We see ER workers, male dominated and lower wage, but this is an important piece, but it's also a lower number. We have to focus kind of on these ones with the most people. Okay, so I'm not going to do it now. We're about out of time, but I could have changed the could also have had the Shiny application explore that axis alongside exploring the disparity. Could have had a choice between those two. All right, well, that's the time we have. I had a good time exploring this data. A happy International Women's Day occurring this week, and I'll see you next week.